Hello, my name is Pascal Linane.
And I'm Greg Tessier, and this is our Iam3D 2016 entry.
Moving on vertical ice is unlike moving on any other terrain. To climb efficiently, we use stiff boots, crampons, and ice tools. However, the best gear on the market means nothing without proper technique and training. Climbing vertical ice uses a balance between kicking with the crampons and swinging of ice tools to methodically work your way up. The most physically challenging part of ice climbing is managing the lactic acid buildup in a climber's forearms due to overgripping ice tools. There are ice tools on the market that address this issue, however they tend to focus only on vertical ice and are more expensive. Current alpine ice tools are the most versatile with a slightly bent shaft and a straight handle. We created a modular grip that moves the climber's hand to a more horizontal position, which reduces the gripping force required and subsequently reduces the lactic acid buildup.
We performed finite element analysis on a simple grip to make slight geometry tweaks before final printing. The first test here, 25 pounds, resulted in a peak stress of 3.1 megapascals, which implies roughly 10 to the 8 cycles to failure. Our second test, roughly 250 pounds, was a worst case, and it resulted in a peak stress of 30 megapascals, still lower than ABS yield of 40 megapascals. The peak stress in both of these tests resulted in the front at the bottom due to the spreading of the grip across the handle over time. Here you can see three different tools. The tool on the left was the unmodified version of the tool we used for testing. The tool in the middle is meant for more vertical ice climbing, and the tool on the right has one of our 3D printed grips already attached to it.
Then it was time for field testing. For testing, we took the tools and grips out for a day of climbing. The day began with using the grips at the base of the climb, then proceeded to use them for a full climb. A major concern we had was how they would hold up in colder temperatures. After being stored in temperatures reaching minus 15 degrees Fahrenheit and used at temperatures of 20 degrees Fahrenheit, they had no signs of obvious wear. For our final test, we compared our modified ice tool to the unmodified one. The modified tool resulted in much less form fatigue, proving our design successful.
3D printing permits easy modification of pre-existing designs. A common complaint of ice climbers is that grips may be too large or too small. But because these grips are 3D printed, that means that you can make easy modifications within a matter of hours. These grips are durable and moddable, something that can benefit the sport of ice climbing and something that will increase the accessibility of ice climbing at higher levels.